Okay, so this is a free response question from 2016, and it's number 6, which means it's no calculator. It is giving you a table of information about 2 different functions and the associated derivatives at 4 different points, 1, 2, 3, and 6. And it's then asking you to work with that information in various ways. This is a good one in terms of forcing you to show products or show process. Sorry, I'm getting ahead of myself with what we're going to be doing, but with showing process and then not being as computation heavy. So I think this particular year, this is going to be a valuable thing to focus on. And while none of us can predict exactly what we're going to see, I think that it's definitely going to be process heavy, which this problem is. So let's get to it. The first one, part A, is saying we're going to define this third function, k of x, is f of g of x. So it's a composite function. Write an equation for the tangent line to the graph of k at x equals 3. You're not going to be responsible for actually figuring out what k is, just writing a tangent line to it. So tangent lines always are going to take that same format. And you can just leave it in that format once you have it, unless you're specifically told otherwise, but I can't imagine a situation where that would happen. So we need to come up with an equation at x equals 3. So we've got our x value. So I'll put that in for x1. And then I need a y value for this thing. Well, a y value, let's see, that would be f of g of 3. That's what k is defined as. So f of g of 3. Well, let's see, g of 3. If I go on this list here, that's 6. So I'm going to pull that off the list. So then I want to know, okay, what's f of 6? So f of 6 is 4. So my y value is 4. So I'm going into the table and I'm picking out the correct y value, which would be 4. And then I need to come up with a slope. And so to come up with a slope, we need to take a derivative. And to take a derivative of k, so k prime, that's going to be the derivative of the right-hand side. Well, that's the derivative, and that's let's see, I'm going to get myself a little more space. So I'll go over here. So k prime, that's going to be the derivative of the outside, leave the inside alone, times the derivative of the inside. So this is what I mean by process-oriented. It's not an actual function you're operating on in terms of like power function or using some kind of mechanics or a memorized rule. You're showing that you know what chain rule is and how it works. And you're doing it, with this just generic expression. So then we've got f prime of g of, and we're plugging in a 3 times g prime of 3. So now we're going to go to our table, and I'm going to say that's a multiplication. Well, g prime of 3, that's 2. So this one is a 2. G of 3, we already said that was a 6. I already circled that one. We used that once. And I'm going to take f prime of 6 times 2. So f prime of 6, that's this 5 value up here. And I'm wondering if by the end I'm going to end up circling all these values. We'll see. So we've got 5 times 2, which then the slope value would be 10. On this problem, they actually assigned 2 points for coming up with the slope value, which you would need to do the process in order to get there. And I think, it's important to, particularly this year, to get in the habit of showing the steps. So they might award step points. Here they just award the slope to be 2, and then they give you a point for the correct tangent line, no matter what format you choose to put that in. So it would be 10 times x minus 3. And they don't ask us to do anything more with that. So that just gathers a third point on this one. So that's part A. That's the first part. Writing an equation for a tangent line to the graph at x equals 3. Okay, so in part B, they're going to ask us to use a quotient rule. And again, they're going to ask us to do it in a way that's going to highlight your ability to just show you know what quotient rule is. So finding h prime of 1, well, let's get an expression for h prime. So that's going to be low, just low f of x times d high g prime minus high g of x d low f prime of x, all over low squared. And here's our generic expression for our derivative. They want us to evaluate this thing at 1, so h prime of 1. So we want f of 1, g prime of 1, g of 1, f prime of 1, and then f of 1 down below. So we're plugging a 1 in everywhere where x shows up. Well, let's see, f of 1. That's a -6. So there's our negative 6. And then g prime of 1. That's a 2. So I've got -6 times 2. And then I've got minus g of, oops, that wasn't g prime. G prime is 8. Mr. Klusnick making an error. So what I'm going to do is exactly what you would do on the test. If you made an error, you would get out your handy eraser and you would erase what you did wrong. And then you would get back your writing utensil and you'd say that should have been an 8. And I'm just foolish for writing 2. So there I've got -6 times 8 minus, and then I've got g, so I'm going to use that 2 right here, times f prime of 1, which is 3. So look at that, I'm really getting my circles in up there. Then I've got f of x. Well, f of 1, we said that was -6, so I've got -6. I'm going to square that on the bottom. So then I've got -48 minus 6 over 36. And technically speaking, this is a free response, so any equivalent expression should be taken. I would say if there's some easy simplification you could do, like on this one, top and bottom, you definitely can divide both of them by 6. Probably, I'm thinking there's an 18 in there, that if we divided the top and the bottom by 18, I think 18 fits into 36 twice, and I'm pretty confident 18 fits into 54 3 times. You should boil this thing down to -3/2. And that would be the derivative value for h at 1. That actually only gets you a point, and then coming up with an expression for h prime gets you 2 points. So this is going to generate 2 points, and the actual answer is just going to generate a point. So again, process focused. Part C, the last piece of this problem. So we've got evaluate from 1 to 3 the integral of the second derivative of f with a 2x in there. So let's see here. So we've got 1 to 3 f double prime of 2x dx. Technically speaking, this requires a u substitution, and I would say if you're even on the fence about showing it, show it. We need to make u equal whatever in there, and then du would be 2 dx, and then we get our half du is dx. And let's see, so now I'm going to plug in, and I'm going to leave the bounds off because I know I'm doing the second derivative, and I'm going to have this half multiplier out front. So if I take the integral of a derivative, it knocks it out and becomes the function. If I take an integral of a second derivative, it does away with one of the primes. So I've got f prime of u. But of course, we define u to be 2x, so it would be half f prime of 2x. And then we are going to evaluate. Now that I put the x back in, we're going to evaluate from 1 to 3. And you could certainly rebound this thing and keep with a u, and that's fine. There's no penalty for doing it one way versus the other. They're both equally good. And when you plug in your 3, I'll just leave my half out here. We're going to have f prime of 6 minus f prime of 1. And again, there we're going to need to just go back to the table and figure out what those values are. So we get half of f prime of 6 minus f prime of 1. Well, f prime of 6 is a 5. F prime of 1 is a 3. So let's see, it'd be half times 5 minus 3. Is that right? Do I honestly get that? Let's see, let me make sure I did that right. F prime of 6 is 5. F prime of, I have a feeling I did something incorrect here. I think I made an error here when I put the 1 in. 2 times 1 is actually 2, in case you were wondering about that. So that should be f prime of 2, which if I go back up here, f prime of 2 is a -2, which got me another circle on my chart. That was kind of fun. So let's see, that's a -2. So minus a -2 is really just plus 2. And then I've got half times 7, and that equals 7/2. You do get a point for the final answer, which is 7/2 on this one. And that would have been tricky to get to that answer without having made that catch that we made right there. And then you get a point, 2 points for correctly doing the integral. And so going through this process and correctly integrating gets you 2 points. So 3 points per section. And then this one generates an answer of 7/2, and I'll scroll back up here. So you can see on the table there were a number of values we didn't use. And I know it seems goofy that I was circling everything, but I just wanted to indicate what we did use and what we didn't use, so that when we get done with the problem and you look back, you realize they gave us some unnecessary information. In fact, some of those things that I didn't use, had you done a wrong step somewhere, potentially you would have used those values and generated an incorrect solution. So those aren't just unnecessary values they're throwing in. They're unnecessary values that are linked to common mistakes. And you can see that, it's kind of a random assortment that we chose up there for what we needed. But it wasn't everything, it was just the majority of things. So for whatever that's worth, know that you're not necessarily going to use everything that's in a table, but that you're going to be expected to know which pieces you need when, type of deal. So that is, again, 2016, question number 6.